the project is openly called Database as a Service. Uh, there is a fancy name for it we use. I don't think I can actually use it, but I think you guys are smart enough to abbreviate it in a fashion that might be really funny for you. It sounds something similar to SAS. So you can think about it, what it is. So what is the problem set? So provisioning a database in current scenarios, it takes almost like 8 weeks is a very long time. That's for the slide. It almost takes weeks to actually get an instance when when a developer wants a database for their app or anything they want to work on. So this whole flow looks a very time consuming process to just get a database for your app. Your dev team need a database, and then it requests a DBA service. You raise a ticket. That ticket is being reviewed. There's a planning session done on the ticket. Then you need to get approval from like various hierarchies. Then you submit a security request. Then the then the security, then your network, IT guys will slice a chunk for your DB. You will get a VM. There would be a DBA who will be doing the tuning and other things based on your requirements. If it's an OLTP, there would be a different tuning for it. If it's a ETL job, then there is a different tuning for the DB. So he will do the tuning for it, and he will write the scripts for maintaining, backing up, any other feature that you might have requested. There would be an approval for it, and then he will design the schema, and finally you will get the credentials. That is the only thing that that the developer wants for their databases. So we want to automate these whole features that if a developer requests for a database, he doesn't have like he don't have like he doesn't have to like wait for 8 weeks, 1 week to 8 weeks for just a database. There are like lots of other problems also associated with the database. It's like if something goes wrong, the app developer doesn't know what happened with the database. The platform team only cares about maintaining the VM. There might be data corruption in the database, but the VM is running. So your platform engineer will not be able to understand what actually happened with your database. And when actually a DBA is being called to fix the things, he will smash his head thinking about there might be better tuning based on the requirement that is being done by the developers for the database. And he has to deal with like lots of issues that he didn't think about before handing over the database to the developer. So a database is, for an overview from outside, just looks like server which runs your database. But there are a lot of tuning that need to be done based on the use case of your database. There are tune configuration based on your workload. There are management and automated things that need to be done for your database for making it highly available. There's a backup and restore services that you need to add to database. There is an upgrade patch services that you need to associate with the database. And to secure the database, there is like credential management on top of it. There is an auditing process. There are certificates that need to be rotated based on how long of a period you're going to use the database and what type of certificates you have associated. It can like expire and suddenly you cannot connect to the database even if it's like running. For security, you want to encrypt the data in a way where that is supposed to be non-breakable, but that's a objection. That is very opinionated version of it. Then there is a scalability associated with the database that initially you might have requested for a smaller database, but based on your use case, it might have increased, or like you might require more space. But again, you have to like request for a new database that again will take 4 or 5 weeks, and there is data migration that need to be done. So this problem is again there. Scaling a database is again a big problem. And then you also want a dashboard to see what's happened to your database and how many queries are going in, what type of performance you're getting from the database. And then there's a CLI option of it. Like you want to connect just to the database without any app or anything, and want to see or query, generate the queries from it. So a database is not just a database. There are like hundreds of services that are around it, wrapped around it for maintaining and making sure it's like up and running. So what our team is doing basically, it's moving this rack of servers that is always a problematic thing to cloud services. And by the way, this rack of services is really big. If you think your graphic computer, what you have right now, is big, the scale of the servers are like 192 cores, 3 TB of RAM, and just the primary disk is like 38 TB. So these are the smallest scale of fast blocks we have right now, what we are like replicating it on cloud. And playing with them is really fun because the power and performance you get from the servers is like, it's really interesting. So the solution we are planning right now is migrating it to Kubernetes. I will not elaborate a lot about Kubernetes right now because it will take more of a time and we don't have that much right now. So what Kubernetes does, it provides an abstraction layer for all your deployment and automation framework. And it's a container-based system. So whatever you're deploying can be easily replicated